Now let's see how AWS KMS achieves envelope encryption. So first step is creation of key. So I will just quickly, we will do this again, but for now I will just quickly create one key with everything default. And here we created a symmetric key. So when we create this key, what happens is that AWS HSM or hardware security module creates one key which is called HSM baking key or HBK. Now this device will be used by other customers as well, and this HBK can't always live inside this module. That's why this HBK is encrypted and stored as exported key token or EKT in some durable storage. Point to remember here is that this HBK is actually the super secret key which we talked about earlier. Now it's exported and stored as EKT. Also, the key which we have created in KMS console, it do not contain actual key material. Instead, it just contains a pointer to the EKT. So this key which we have created here, it will not contain any actual key material. Actual key material is at EKT and it's just a pointer. Now step 2. Suppose we want to encrypt some message. So this will be the workflow for that. And this workflow happens when we make generate data API call to AWS KMS. And when we make this generate data key API call, we either pass alias of key or ID of key, this thing. And this key, we know that it is pointer to exported key token. So exported key token is taken and sent to AWS HSM. Then AWS HSM decrypts EKT to restore HSM baking key, which is our super secret key. And then this super secret key is added with some random number or nonce, and a new key called derived encryption key or DEK is created. Also, this HSM only creates another key called data key, and this data key is encrypted using this derived encryption key. Now at this point we have data key and encrypted data key. These are returned as part of generate data key API call, and object is encrypted using this plain text data key or data key. Then encrypted object and encrypted data key are stored together and plain text data key is discarded. So at this point we have encrypted object and encrypted data key in our disk. In step 3, which is decryption process, we have encrypted data key and encrypted object, but we can't use encrypted data key to decrypt it. For this we make decrypt API call, and as part of decrypt API call we send encrypted data key, and this data key contains information regarding nonce, this nonce which was used to create derived encryption key, and it also contains information regarding which KMS key was used to create this data key. So from that information EKT is recovered, and from EKT HBK is created. Since we have nonce again, we can create DEK again. Once we have derived encryption key, we can decrypt data encryption key, because if we see here, this derived encryption key was used to encrypt data key in first place. So again, we can use it to decrypt and then return data key. Now we have data key in plain text, and it can be used to decrypt our object or message. So what's important here is that we can see the actual key, SBK or DEK. These are the main keys which are being used to create data key, and they never leave HSM module in unencrypted format. Also, for each generate data key API call, data key is created and returned, but there is no need to store information regarding this in the KMS. So that helps in the scalability part. Also, each time we want to decrypt the object, we have to make this decrypt API call to KMS, and hence each decrypt operation can be audited.